Bismillahirrahmanirrahim. Assalamu alaikum, my YouTube students. Dear students, today we are going to discuss exercise 3.5, question number 1. But before going directly towards exercise 3.5, let's discuss some important formulas. So, list of the derivatives of basic standard functions. Here we know that if we are having function y is equal to sine of x, then its derivative would be cos of x, and cos of x derivative would be minus sine of x, and if we are having function tangent x, then its derivative would be secant square x, and secant x derivative would be secant x into tangent x. Cot x derivative would be minus cosecant square x, and cosecant x derivative would be minus secant x into cot x. And here you can see if we are having function sine inverse of x. If we are having the function sine inverse of x, its derivative would be 1 by under root 1 minus x square. There, whatever would be in the place of x, we have to take the square of it. Fine. And if we are having function cos inverse of x, its derivative would be same as sine inverse of x derivative, but negative sign will be coming over here. Fine. Now tangent inverse of x derivative would be 1 by 1 plus x square. And cot inverse of x derivative would be same as tangent inverse of x derivative, but the negative sign will be coming over here. Now cosecant function, if the function is cosecant inverse of x, then its derivative would be minus 1 by x into under root x square minus 1. Now if the function is y is equal to sine inverse of x, its derivative would be same as cosecant inverse of x, but negative sign will not be coming with it. Fine. And if we are having y is equal to log x to the base a, then it would be 1 upon x, 1 upon x into ln a. For suppose if we are having log x to the base 5, then it would be written as 1 upon x and ln 5. Next one is if y is equal to ln x, then its derivative would be 1 upon x. These were some important formulas, and now let's discuss some hyperbolic formulas. Now here we are having some derivatives of hyperbolic functions. Sin h of x is equal to cos h of x, and cos h of x is derivative would be sin h of x. In other case, here you can see the cos derivative is minus sine of x, but here when we are having the hyperbolic functions, so cos derivative would be cos hyperbolic of x derivative would be just sine hyperbolic of x. Tangent hyperbolic of x derivative would be secant h square x, and cot h of x derivative would be minus cosecant h square x. And when we are having cosecant hyperbolic x, then it would be minus cosecant x into cot x. If y is equal to secant h of x, then it would be its derivative would be minus secant h of x into tangent h of x. If we are talking about inverse hyperbolic functions, then sine hyperbolic inverse of x is equal to 1 upon x square plus 1, and cos hyperbolic inverse of x is equal to 1 upon x square minus 1. Here it would be plus 1, and here it would be minus 1. Tangent hyperbolic inverse of x is equal to 1 by 1 minus x square, and cot hyperbolic inverse of x is equal to 1 by 1 minus x square. Here, and if the function is cosecant hyperbolic inverse of x, then its derivative would be minus 1 by x into under root 1 plus x square. And if y is equal to secant hyperbolic inverse of x, then its derivative would be minus 1 by x under root 1. Here it would be plus, and here it is minus x under root 1 minus x square. Here we know that log x to the base a, and in this one, if a is equal to 10, then it is considered as common logarithm. And if we are having a is equal to e, then it would be considered as natural logarithm. Log x to the base a is equal to, if if a is equal to e, it will be considered as natural logarithm, and we can write log x to the base a is equal to ln x. Now let's discuss some important properties of logarithm. The first one is whenever ln ab is there. Number second one, ln a divided by b over there. And if we are having ln a raised to the power m is there. So how we are going to resolve them? So if we are having ln a into b, when we will open it, it would be ln a. The multiplication will be converted into plus ln b. When ln will applied on a into b, then it will be equal to ln a plus ln b. And when ln is applied to a by b, so it will be ln a minus, that division will be converted into negative, ln a minus ln b. And if we are having that power ln a raised to the power m, then this power comes out and ln a will be there. So I hope you have understood all three properties of ln, and these are very important, and these all properties will be used in exercise 3.5. You can take screenshot of it as well. So now let's move to exercise 3.5. Here we have exercise 3.5. Here we have exercise 3.5, question number 1. And in question number 1, we have to differentiate the following with respect to x. And its first part is x square plus 2 raised to the power x. We can take let y is equal to x square plus 2 raised to the power x. Taking d upon dx on both sides of equation. So it would be dy by dx. So d upon dx will be x square, will be with x square, and d upon dx will be with 2 raised to the power x as well. So here you can see that this is the formula, x raised to the power n. So d upon dx on x raised to the power n is equal to, n will come out, x raised to the power n minus 1. So same formula will be applied on that as well. 2 will come out, x raised to the power 2 minus 1 will be 1, and the derivative of x will be 1, plus here we have the formula a raised to the power x whole derivative will be equal to a raised to the power x ln a. And here in the place of a, it is written 2. So 2 raised to the power x derivative will be 2 raised to the power x ln 2. So we will write 2 raised to the power x ln 2. So its answer would be 2x plus 2 raised to the power x ln 2. So its first part is solved. Now let's move to its second part. That is, its second part is 4 raised to the power x plus 5 raised to the power x. Let y is equal to 4 raised to the power x plus 5 raised to the power x. Now taking d upon dx on both sides of equation. So here it will be dy by dx, and this would be d upon dx 4 raised to the power x plus d upon dx 5 raised to the power x. And we know the formula We know the formula that whenever we are having a raised to the power x derivative, so it will be equal to a raised to the power x ln a. Here in the place of a it's 4. So 4 raised to the power x derivative 4 raised to the power x derivative is equal to 4 raised to the power x ln 4. Same 5 raised to the power x derivative is equal to 5 raised to the power x ln 5. So here we are going to replace it as 4 raised to the power x derivative is equal to 4 raised to the power x ln 4, and 5 raised to the power x derivative will be 5 raised to the power x ln 5 is the answer. Now let's move to its third part. Let y is equal to e raised to the power tangent x plus cot x. Now taking derivative on both sides of equation, we know that if we are having e raised to the power f of x, derivative will be e raised to the power f of x, and afterwards derivative of this function. And if e raised to the power f of x means the function will be there, so e raised power f of x will be same, and then we have to take the derivative of this function as well. So here y derivative is equal to e raised to the power tangent x plus cot x, and the derivative of tangent x plus cot x will be there. So its derivative of tangent x is secant square x plus derivative of cot is minus cosecant square x. So its derivative is equal to tangent x plus cot x and secant square x minus cosecant square x. It can be written as secant square x minus cosecant square x into e raised to the power tangent x plus cot x. Here is the answer. I hope you have understood this part as well. You can take screenshot of third part. And the fourth part is e raised to the power tangent x square. So now let's solve the fourth part. Let y is equal to e raised to the power tangent x square. So taking derivative on both sides, so it becomes dy by dx is equal to d upon dx e raised to the power f of x derivative is there. So we have to write down e raised to the power f of x dot f dash of x. Fine. So e raised power tangent x square will be same. So afterwards we have to take derivative of tangent x square. The derivative of tangent x square is secant square x square, and afterwards here you can see the derivative of x square will also be coming. So y dash would be equal to tangent x square and secant square x square, and this derivative will be equal to 2 of x. After arranging it, we can write it down as 2x secant square x square into e raised to the power tangent x square. And this is the answer of fourth part. Now let's move to its fifth part, that is e raised to the power 2 ln x plus 1. Let y is equal to e raised to the power 2 ln 2x plus 1. Here I have told you in the properties of logarithm that a raised to the power m is equal to m into ln a, and same if we are having this m ln a, then it can be written as ln a raised to the power m. Fine. And we know that e raised to the power ln are cancelled with each other. So by taking ln on both sides of equation, taking derivative on both sides of equation, so it can be written as ln 2x plus 1 whole square. This square can become power of it. As ln is there, so this square can become power of 2x plus 1. And ln and e are cancelled with each other. Now derivative of y will be equal to d upon dx 2x plus 1 whole square. And if we are taking the derivative of it, so 2 will come out and 2x plus 1 raised to the power 2 minus 1, that would be 1. And again derivative of 2x plus 1. So here it would be derivative of 2x will be 2 and one derivative will be equal to 0. So 2 to the 4 into 2x plus 1. This is the answer. Now let's move to its fifth part, that is log x to the base 10. Let y is equal to log x to the base 10 is there, and taking derivative on both sides of equation. So here we have now y dash is equal to, we know the formula that says log x to the base a derivative is equal to, its derivative is equal to 1 upon x ln a. So here in the place of a it's 10. So log x to the base 10 derivative is equal to 1 upon x ln 10. In the place of a, 10 will be replaced. So we can write it down as directly x ln 10. This would be answer. Let y is equal to e raised to the power x by x square plus 1. Now taking derivative on both sides. So we know the formula. If we are having u by v, so its derivative will be equal to v square, v derivative of u minus u derivative of v. So same we are going to use over here as well. So in the denominator x square plus 1 whole square will be coming, and in the place of u e raised power x, in the place of v x square plus 1, x square plus 1, and derivative of e raised to the power x minus e raised power x same, then derivative of x square plus 1. So here we know that derivative of e raised power x is equal to e raised power x. So x square plus 1 e raised to the power x minus e raised to the power x, and derivative of this would be equal to 2x. One derivative would be 0. X square plus 1 whole square will be coming. And by derivative we can take e raised power x common. So the remaining will be x square plus 1 minus 2x divided by x square plus 1 whole square. And we can write it as e raised to the power x minus 1 whole square, x square plus 1 whole square. We know that a minus b whole square is equal to a square plus b square minus 2ab. Same, x minus 1 whole square is equal to x square plus 1 square minus 2x. So here this is the open form of this. We can close it x minus 1 whole square. Fine. I hope you have understood this question as well. Now let's move to its eighth part. Its eighth part is x square plus 2 raised to the power x plus a raised to the power 2x. So let's resolve this. Let y is equal to x square plus 2 raised to the power x plus a raised to the power 2 of x. Let y is equal to this, taking d upon dx on both sides of the equation. So we can write it derivative of y as well. So here d upon dx x square we have to take, plus derivative of 2 of x we have to take, and derivative of a raised to the power 2x. Derivative of 2 raised to the power x we have to take, and the derivative of a raised to the power 2 of x we have to find. So y dash is equal to derivative of this power come out, and x raised power 2 minus 1, it would be 1, plus, so derivative of x square will be 2x, and derivative of 2 raised to the power x. We know that a raised to the power x derivative is equal to a raised to the power x ln a. So here in the place of a it's 2. So 2 raised to the power x ln 2, plus same, if we are having a raised to the power f of x, so its derivative would be a raised to the power f of x ln a into f dash of x. It means we have to take derivative of this f of x as well. So here a raised to the power 2 of x ln a will be there, a raised to the power 2 of x ln a, and the derivative of this 2 of x. 2 of x plus 2 raised to the power x ln 2, plus this derivative would be equal to 2. So 2 a raised to the power 2 of x ln a, and this would be answer of this question. Here we are having y is equal to ln x whole raised to the power x. Whenever we are having functions power function, so we have to take out this power. So for that purpose, we are going to take ln on both sides of the equation. So ln y is equal to ln x both ln x raised to the power x, and now this ln takes that power out, so it would be x ln x. So here you can see we are having two functions, first function and that is second function, and we know if we are having u dot v derivative, so it will be u and derivative of v plus v derivative of u. So taking d upon dx on both sides of equation ln x. Fine. First function means u and the second functions means v. Ln x derivative will be equal to 1 upon x. Here we are having ln y, so it would be 1 upon y dy by dx. As this is not function of x, so dy by dx will be coming with it. X dot ln x, it is u dot v. Now u dot v derivative will be u v derivative. U will be same, that is x, and derivative of v ln x derivative plus v will be ln x and derivative of u, that is actually x, and the derivative of ln is equal to 1 upon, and here is the function of ln, so ln x, and afterwards whatever in the denominator we have to take derivative of it, so ln x derivative. And if we are having ln f of x, so 1 upon f of x, and then derivative of f of x will also be coming. So here this is a function. So ln will take it in the denominator 1 upon ln x, and then the derivative of this denominator function ln x derivative will be there. Fine. Plus derivative of x will be 1. We can write x by ln x into ln x derivative will be again 1 upon x. Fine. Plus ln x. This x will be cancelled with this. That is equal to 1 upon ln x plus ln into ln x, and dy by dx is equal to y is divided over there. When it goes to the other side of the equation, it will be multiplied, and y value was, we have taken y is equal to ln x raised to the power x. So let's substitute the value of y, that is ln x whole raised to the power x, and 1 upon ln x plus ln x, and this would be answer of this question. Now let's move to its 10th part, and that is very important part. 10th part ln e raised to under root e raised power 3x plus e raised power minus 3x. Let's take this is equal to y. Let this is equal to y. Fine. And taking afterwards we have to take derivative of these both two functions. Fine. So it would become y bar is equal to, yes, ln any function. I have told you that this part, that ln f of x derivative is equal to 1 upon f of x into derivative of this f of x. Fine. So here the same formula we are going to use. So it would be 1 upon e raised to the power 3 of x plus e raised to the power minus 3 of x, and then derivative of this. So y bar is equal to 1 upon e raised to power 3x plus e raised to the power minus 3x, and derivative of this is equal to 1 upon 2, power comes out, and we have to take minus 1. We have to subtract minus 1 from the power. 3x plus e is for minus 3x. We know this under root means 1 upon 2. So powers come out, and we have to subtract 1 from the power, and then afterwards taking the derivative of this d upon dx of e raised to the power 3 of x plus e raised to the power minus 3 of x. So let's move on. So y derivative is equal to 1 upon e raised to the power 3x plus e raised to the power minus 3x into 1 upon 2, and this answer will be minus 1 upon 2, and when it goes down, so it will be positive 1 upon 2. Hopefully you have understood this. This is equal to 1 upon 2, and derivative of e of x is e of x, and the derivative of 3 of x plus derivative of this would be e raised power minus 3 of x, and then minus 3 of x derivative. We can write it 1 upon 2 as under root e raised to the power 3 of x plus e raised power minus 3 of x, and 3 e raised to the power 3 of x. Derivative of 3 of x would be 3 plus e raised power minus 3 of x. Derivative of minus 3 of x would be minus 3. We can take 3 common, and we have e raised to the power 3 of x minus plus minus minus e raised to the power minus 3 of x divided by this is 2, and same thing can be written as e raised to the power 3 of x plus e raised to the power minus 3 of x. These are 2 times, so the whole square will be coming with it and square will be cancelled with this the root. So here we are having 3 e raised to the power 3x minus e raised to the power minus 3x divided by 2 e raised to the power 3x plus e raised to the power minus 3x. And here we know that tangent hyperbolic of x is equal to e raised to the power x minus e raised to the power minus x divided by e raised to the power x plus e raised to the power minus x. Here you can see y dash is equal to 3 by 2 e raised to the power 3x minus e raised to the power minus 3x divided by e raised to power 3x plus e raised to power minus 3x. Fine. So here we have in the place of x, here it is 3x. So we can write down y dash is equal to 3 by 2. Y dash is equal to 3 by 2 tangent hyperbolic 3 of x. And this would be answer. This 11th part is equal to ln sine ln x. So here let y is equal to ln sine x, ln sine into ln x. Fine. Let's take the derivative of this. Taking derivative on both sides of equation, it becomes y dash dy by dx is equal to y dash. We know that whenever ln f means the function derivative we are going to take, so it would be 1 upon f and derivative of f. A derivative of ln is equal to 1 upon sine ln x and derivative of this sine ln x. Fine. And derivative of sine ln x is equal to cos ln x into derivative of ln x. Same thing will be carried forward and ln x is equal to 1 upon x. So here cos ln x divided by x sine ln x, and this would be equal to cos upon sine is equal to cot x is equal to cos x upon sin x. So we can write it down as 1 upon x cot ln x. So I hope you have understood this 11th part as well. Now let's move to its 12th part. In 12th part, we are having ln tangent x by 2 plus pi by 4. Let this is equal to y, and afterwards taking derivative on both sides of equation dy by dx is equal to derivative will be equal to 1 upon f and derivative of this function tangent x by 2 plus pi by 4 we are having. Now the derivative of tangent x by 2 plus pi by 4 derivative. So y dash is equal to derivative of this is equal to tangent derivative is equal to secant square x by 2 plus pi by 4 and again derivative of x by 2 plus pi by 4. So y dash is equal to derivative of x by 2 is equal to 1 upon 2 and pi by 4 is equal to 0. So here we are having y dash is equal to into 1 upon 2 is equal to tangents is equal to sine x by 2 plus pi by 4 on cos x by 2 plus pi by 4 into secant is equal to 1 upon cos x by 2 plus pi by 4 into 1 upon 2. We know that this cos is secant square is equal to 1 upon cos square. Cos is cancelled with 1 time of cos. So y dash is equal to 1 upon 2 sine x by 2 plus pi by 4 into cos x by 2 plus pi by 4. We know that 2 sine x into cos x is equal to sine 2 of x. Y dash is equal to 1 upon. So we can apply this formula. Sine 2 in the place of x it is there x by 2 plus pi by 4. We can take 1 upon 2 common from these both two. 1 upon 2 x plus pi by 2. Fine. So 2 is cancelled with 2 and here we have 1 upon sine x plus pi by 2 and pi by 2 is equal to 90 degree and sine x plus 90 degree is equal to cos of x. So y dash is equal to 1 upon cos of x and y dash is equal to 1 upon cos is secant x. This is actually answer of 12th part and this is a very important part.